I'll make a difference. Label distribution protocol. TDP means tag distribution protocol. Now, what is the difference between these two? Both do the same functionality. It's an open standard. And this is Cisco's protocol. So mostly we use LDP. Okay, it uses UDP and TCP port number 646. It uses UDP and TCP port number 71. Okay, here we can run MD5 authentication. Here there is no authentication. Okay, so now, as I was explaining you yesterday, between these two, there is a concept you can run LDP. Okay, so it should match. Now, there could be a possibility you are running TDP here, but not recommended. See, here in the segment, it should match, but not recommended to use this mix and match. Okay, and if suppose this is your customer edge and this is your MPLS cloud, here you are using LDP. Okay, now I want to restrict the customer that it should not form any LDP neighborship with me. So here on the inbound, I will put an ACL that will deny TCP UDP 646 or 711, both. So that I'll make a note, so that customer will never form MPLS with service provider. Never form MPLS with service provider. Okay, so keep these things in mind. And then we have two different tables called lib table and lfib table. Okay. Now, lib table, I'll just make a note. Actually, what is lib table? I have told you. First, you have to run OSPF or whatever routing protocol you are running. Your routing protocol will going to create a routing table, which is RIP. As explained before also, that copy will go to the data plane as PIP, and this is your set table. Okay, suppose a table is created like directly connected 10, OSPF 20, OSPF 30, likewise. So what lib table will do, LIB table, okay, label information base table. This is called label information base. It assigns labels to local, like to your routes. Now try to understand, to the C route and non-MPLS route, it won't assign any label, no label assignment. They will going to assign label number 3. This is called null label, meaning no label. There will be an assignment, but label number 3, which is reserved for null label. to directly connected and the non-MPLS route, they will going to assign null label. Apart from that, whatever O routes are there or whatever D route, R route, but no B route, TDP, it won't assign any label. So who will assign label? See 16, 17, 18, 19. That is the responsibility of LIB table. Okay, so both sides, right now you need to understand, they will going to form, suppose two routers are there. Between these two routers, they have, first of all, exchange the OSPF route, reachability is there. Whatever OSPF it is there in the routing table, whatever route are there in the routing table, LIB table will going to assign label to indirectly connected route apart from B route and apart from like directly connected route and C. For directly connected route, B means BGP route and non-MPLS route. It won't assign any label. So you will see label number 3, null label. They will assign. Okay. So let me clear this. Now what will happen? Lib is created, LDP is working. Okay, you have to enable LDP. Once you enable, like I will tell you the commands. Okay, this is created and then they will form LDP neighborship. When they form LDP neighborship, this guy will send its own lib table to him. This guy will send its own lib table. Now this is a kind of a database table. See, we are doing label switching. So according to that, these are our LIB is my database table. Database table. I have information about all the labels. Now once they exchange, with that exchange, a lot of other commands also get an idea. They will going to create something called MPLS routing table. It's called LFIP table. And for your understanding, I wrote MPLS routing table. Okay, which is called label forwarding information base. Okay, so what is the difference? I'll just make a note. Lib table, this table hold all locally generated labels. Locally generated labels. And on the other side, LFIP, this table contain label that are used to switch the packet. Switch the packet. Okay, now try to understand. I'll make a now suppose this is your LSR router. Okay, now means MPLS router. We have a control plane. We have a data plane. So in a control plane, you need to understand you create your routing. See, first of all, OSPF will going to exchange the routes and it will going to create a database table. Those database tables are like EIGRP, RIP, whatever, BGP. BGP we are not using in MPLS, so we won't talk about that. So we exchange the route and we create a database. With the help of that database, you create a routing table, which is called RIP table. Okay, and then MPLS will going to create, and they will form like LDP neighborship, and they exchange LIB. So LDP, LIB, all that thing comes under your control plane. What comes under your data plane is called FIB concept, which is your CEF, and your lib, LFIB concept. Now the MPLS routing table will be there in the data plane. That's why it is pretty fast. Okay, so these are in the control plane, this is in the data plane. Okay, so now if I will give you a summarized view, what happens is, first of all, you will going to run a routing protocol like OSPF. Now it will going to create a CEF table which is required, which is actually CEF will going to create FIB table. Now with this FIB, first of all, okay, you have to enable LDP. Now LIB table is created, and between the two routers they form LDP neighborship, and your each LIBs are exchanged, and then after the exchange of LIB they create LFIB, the routing table of MPLS. This is called database table. This is called routing table. Okay, this is somehow it works. Okay, now I'll again make a topology where I will show you push pop and all those things. First of all, I will show you without penultimate hop popping. Then I will show you with the penultimate hop popping. Okay, now I will going to use the correct terminologies. What table lookup will happen. So here we have, today we need to understand this concept. Customer edge, provider edge, P router, provider edge, customer edge. Now from here, a packet will hit. Now try to understand, this is your L1, L2, and normal L3. So because this first PE router, this is called your ingress PE router, and this is called your, right now according to the flow, this will be our egress PE router. Now because you have initiated normal packet on the provider edge, it won't check the MPLS routing table because it encounters L1, this de-encapsulate L2 and L3 encounter. When it encounter L3, it checks the CEF table. Now try to understand, CEF is very important. Because in a CEF only they have written, when I will do the practical you will understand, it is written push one label, push a label. Suppose label number 17. In the CEF that information will be there. Okay, so fine, you did push 70. So what it will do, it will going to send this packet like L1, L2, L3, and L2.5 label number 70. Now because now when it de-encapsulate, I'll make a proper note here. When you de-encapsulate, you L1, L2, and L2.5. So you have encountered MPLS header. So it will be MPLS routing table. So no need to write this MPLS routing table. We will check something called LFIB lookup. Now with the LFIB lookup, we will do something called swapping. Now there could be a possibility it could be locally significant, so it could be same, or it could be different. So L1, L2, L3, and L2.5. Suppose 19. Label is 19 swap. Again, one more packet will reach here. Because it encounter L1, L2, and L2.5, it will do again MPLS lookup. And again, it will do something called swap and send it to the next swap. So here, L1, L2, L3 could be a possibility. Layer 2.5, we have 22. Now, it reaches to the provider edge. Because again, it encounter label, so it will do a route, MPLS route lookup, LFIB. Now, because in the table itself, when we do practical, you'll understand it was written that pop it. When it pops, see it will reduce this and L3 will be there in the picture. So to do L3 lookup, we need to again check the Ceph table. Okay, and then packet will send it to the next swap. Okay, so if in the last router you will notice we have a lot of lookups. The first lookup is LFIB lookup, then you popped it, and then again Ceph lookup, and then you have sent it to the next swap. Okay, so this is your normal flow. What we discussed with proper tables: push, swap, and pop. So now, if you will notice in the last egress P router, a lot of lookups are there. MPLS routing table also, normal unicast routing table also. So how to reduce that effect? So that's why they come up with a concept of PHP, penultimate hop popping. Let's make a note. Penultimate hop popping. Okay, what this concept will do, this is your customer edge, provider edge, P router, provider edge, customer edge. Just give me a second. Give me 2 5 3 minutes, I'll come back. Okay, got call. Sorry for that. Okay, now what will happen in penultimate hop popping? A packet will reach here, okay, and normally it will come with same thing L1, L2, L3. Okay, again it will do a self lookup, and normally it will do a push. Okay, and again when packet will reach the next hop, because it encounter MPLS label, so first will be your MPLS routing table, which is LFIB lookup. Because of this label, this table, it will do a swap. Now, what penultimate hop popping is saying, this second last router, the last P router and the second last router of the cloud, it will going to remove the tag. Meaning, now see the effect, because I have not removed the above one. So if you will notice now, the packet will reach here. It will do a LFIB lookup. In this lookup itself, it is written that pop the packet. So when it will pop the packet, you need to understand only L1, L2, and L3 is going. So when it will hit the PE router, egress PE router, it will encounter again L3. So it will check the self lookup and it will send it to the next hop. Now, if you will notice, I'll just make a point, this side only. Okay, I not included that part. This side. If you will notice here, he is doing swap. Here I am doing pop. Now we will do the default is this now. Okay. Here we are doing double lookup. Now here only self lookup and go out. So what happen is with the penultimate hop popping, your latency will go down. Okay, it will be reduced and it will become more efficient. So if you want to explain PHP, okay, I'll just give you a few points which will help you. So this is called penultimate hop popping concept. So in penultimate hop popping concept, see this penultimate hop popping. PHP. Okay. Used in this concept is used in the first of all label switch path in MPLS cloud to improve in the MPLS operation, improve the efficiency in the MPLS operation. Now, what PHP does, PHP remove the requirement of meant for a double lookup to be performed at egress PE router for a, as I have shown you, double lookup to be performed on egress PE router. Okay, so now what actually will happen, the lib table, practically I will show you. The lib table will display value of implicit null to pop it. When it is written implicit null, means pop it. pop the. Okay. So overall, if I will summarize this small theoretical part, whatever we were discussing from last 2 days. Okay. First, we have to run IGP. IGP will going to build a routing table. Okay. And then it will be creating FIP using Ceph. Now you have understood why Ceph is required, because Ceph will going to do a push. Without Ceph, push won't happen. Okay, normal routing table won't. There will be no value. I will show you practically. There will be no push concept. Then lib assigns, you enable MPLS, and lib assigns a local label for each route learn. Okay, and then when they become LDP neighbors, so at that time LSR routers share the labels with neighbor using LDP as discussed. I'm just putting a proper words here. Okay, then LSR build their own routing table. Now this lib is your, I'm pointing toward database table again and again, which is there in a control plane. Here's the label information. When you exchange the lib between, as you LSR will share the label, meaning lib information with the neighbor using LDP or TDP. Okay, then LSR routers build their own LFIP table. Okay, and then once your LFIP table is created, they forward the packet based on label lookup. So they forward the packet based on label lookup. Okay. So now you need to understand when we will going to start practical tomorrow, what will happen on this router and this router. Now this MPLS theory is over. A few more things are there theoretical, like I have told you that TTL, what like TTL behavior, that theory is left. Okay, whatever theoretical we have learned so far, push, pop, and swap. First of all, we have to implement that theoretically. Okay. Now, what will happen? Suppose between, like I have a topology. Okay, I'll show you one topology which tomorrow we're going to use. One is, I'll explain you the difference now. One is we are doing MPLS. is this topology. I'll create like one more router here. So this is, it will explain you push, pop and swap. And I'll explain you what I'm going to do tomorrow. One more topology is there, which is the next concept, which is called MPLS VPN. Now that is a combination of VRF plus MPLS and a lot of other concepts. It will become a big concept. So whatever like you have done so far, I'm going to put everything. Like in CCNP mostly you have done static route, RIP route, OSPF, EIGRP, redistribution, all those combination. Okay, MPBGP. So that is for MPLS VPN. So to learn MPLS VPN, we need to learn OSPF and all those things that we have learned. But what in CCIE you have to learn is VRF that we have done, and then MPLS. Apart from that, other things are old. What new thing you will going to learn here? How to enable static route, RIP route, EIGRP route, OSPF route, even BGP route with the help of VRF. Okay, so that will be the later part once my MPLS practicals are over. It will take maybe 2 more days to complete your MPLS. So I'll come back to the topology of MPLS basic. What we're going to do here is, suppose this is your customer edge. This is your customer edge. Okay, this is your PE router. And this is your P router, P router, P router, PE router. So what you have to do here, I will going to run default route. So topology will be big. We have to create default route. Here also we have to create a default route. You can make this topology and save it at your end so that you can do the practical yourself also. Now this particular cloud, here I am running OSPF. In this cloud I am running OSPF. So then after that they will start forming LDP. Now try to understand in LDP, if you have noticed, I have told you LDP use UDP and TCP both. So tomorrow our focus will be between two routers. A lot of concepts are there. Okay, we have a router ID concept, UDP, even see. When you are sending a hello packet, one guy is sending hello packet, that will be done on LDP, UDP concept. Hello packets are sent on UDP with port number 646. When you will going to listen hello from both sides, again this guy will also send a hello on UDP, then they will start forming the neighborship. When they will form the neighborship, they will going to form on TCP. Always remember hello packet will be sent on UDP, but TCP will come when it has to do a form a neighborship and exchange the database. So after that they will going to exchange lib table and done. The neighbor will come up. It is same like your other routing protocol also. Okay, so tomorrow our focus will be on this part. Okay, because here a lot of things are there. See, when you are exchanging the hello packet, source IP will be this, here source IP will be this, but TCP three-way handshake will be done on the router ID. Router ID means the same concept what OSPF use. So that we have to notice, that I will going to show you with Wireshark. But before that, whatever theoretical we have done, is revise that properly so that we can analyze all these things properly. Okay, then I will tell you that labels one, they are giving default. I can assign my own labels also. Okay, that concept. Then I can give manual router ID. Some issue will come in manual router ID. Small tweaks are there. Then I will show you. Then there is a TTL issue here. So that also I will show you. There is a concept of trace out when you will do. There is one issue. So I'll go into over that. I'll explain you all those concepts also. So if you have noticed, a lot of concepts, small concepts are there. And then I have to tell you that on each router, few commands are enabled by default. Few commands are enabled by default. and make sure that these commands should be enabled, otherwise the MPLS won't work. Okay, and OSPF has given a special command that I will show you. So a lot of small things are there which we will going to do step by step. Okay, and then we're going to move towards MPLS, where RD and RT concept we have to learn. And one more thing I will going to teach you. I have not explained you how LFIB is created. So a lot of table combination. Let me complete this particular part. Once this is done, it will take time to depend. Okay, 1 or 2 or 3 days also. Most probably within 2 days or 3 days I'll complete. Then I will tell you how LFIB table is created. Okay, and then we can start with MPLS VPN. In MPLS VPN we have 2-3 practicals. So first, theoretical concept will be very important. Again, it will take a week or more than little bit more time, because initial MPLS VPN theory will be very big, and that will be very important also, because 3 things you need to understand: RD, RT, and we have something called VPN label. Apart from that, other things we have done, so you will going to connect them, but if you have to revise them properly, these 3 things will take a lot of time, like two or I have to repeat again and again, so that your other practical will become easy. So once this is done, MPLS VPN will be done. Okay. So today I'll stop here. Just revise all these things, because a lot of theory now practical part will come, which has a lot of new things are there. So we have to focus here, and basic theoretical whatever I have shown you, push and pop, and we'll check the SEP table. You will see the label, push, pop, what is the command, each and everything we're going to verify now. Okay. So please revise this theoretical part. We'll continue.